What if rockets that are considered the backbone of space exploration, now largely in development, are about to be bested by something even greater? Try to think of ships racing through space at incredible velocities, not propelled by big bangs of chemical flames, but plasma. They no longer dream along the space shuttles, as plasma engines exist in the real world. They are coming as new opportunities that might act as game changers in determining how transportation across space is going to be done. What if, instead of rockets, these engines were powerful enough in their performance? Powerful, leaner, lighter, and capable of reaching distances that have never previously been attempted. Plasma engines might be the spearhead of a new age in space travel. First, let's look at why plasma engines could potentially be destructive to rockets. But before doing so, let us consider what plasma is and why it is so special. Plasma is the fourth state of matter, which goes past the solid, liquid, and gaseous forms. It forms when gases are heated to high temperatures, forcing electrons to disassociate from atoms, thus leading to the formation of a soup of ions. What is also outstanding about plasma is the ability to control it with magnetic fields and electric currents. Plasma cannot evaporate like gases or liquids, but it can be contained, steered, and even driven like a beam, all being major requirements of an efficient propulsion thruster. Here's where things get interesting. When you make plasma raise its temperature to 100 million degrees Celsius, you can start fusion, a process through which stars are generated. If this fusion process could be controlled, the amount of energy produced would be more than achieved by chemical rockets. But there's a catch. What makes this hard to do is the challenge of sustaining plasma at the proposed extremely high and low temperatures to produce power. That being the case, the idea of using plasma in propulsion systems is quite revolutionary. Taking rockets as one of the most marvelous human inventions, I still have to state that they have certain restrictions. The current technology applied in rockets parlays chemical propulsion, which entails the burning of propellants to generate a lot of thrust within a short period. However, rockets are very unpleasant to look at and bulky, not to mention that they come with a lot of inefficiencies where the amount of fuel they can carry is also limited. Components have to devote most of their efforts merely to get out from under the influence of Earth's gravity. After that, they become inefficient technology, especially in long-distance journeys within space. Besides, rockets cannot be refueled or repaired like automobiles as they are used in space. This is a great disadvantage when it comes to missions outside the Earth's orbit. For instance, long-distance missions to Mars are confronted with fuel and efficiency problems, whereas plasma propulsion might be the key to making interplanetary travel faster, more effective, and also more efficient in terms of energy consumption. Now, to know why plasma engines might supplant traditional rockets, let's consider some of the first plasma-driven engines, like China's microwave thruster. In this system, air is sucked in and gets exposed to a very intense magnetic field, and the end product is plasma as electrons are removed from it. The plasma is then locally heated to about 1,000 degrees Celsius, thus generating a thrust on its ejection out of the engine. Thus, it can be concluded that this technology exists today, but is still in the process of development and is quite promising. The system does function. However, as can be seen, it is limited by the sheer power that is needed to produce the level of thrust that would make it comparable to other rocket engines in terms of efficiency now. Now, these plasma engines produce only 6 pounds of thrust per kilowatt, much less than is required for long and heavy space ventures. However, this small achievement proves that plasma has the capabilities to threaten the current established propulsive systems. As soon as we can advance this technology to wider uses, plasma thrusters can easily be the future power source of satellites to space shuttles in the near future. Energy is one of the most critical problems that plasma propulsion has to overcome. This power source requires a great deal of it, perhaps more depending on variations in plasma engine design. For instance, today's battery stores are about 1/20th of the energy that jet fuel does. So what's the solution? Where do we get the extra power? Turbo generators, for example, and other technically advanced electrical power generation systems. Rolls-Royce is in the process of coming up with a turbo generator that could make a record 12,200 kilowatt-hour output. This level of energy could offer the possibility to directly feed plasma engines and become a concrete solution for future aerospace vehicles. However, these units are still mobile and massive and need a huge amount of fuel to power them. They become possible as energy density technology advances, but the concept of a fully functional plasma engine capable of high performance is not out of this world anymore. Microwave thrusters are still an excellent demonstration of the possibility of plasma utilization, but they will be true fusion-based plasma engines that will make much more difference. If we can heat plasma to such temperatures that it can undergo fusion, that is around 100 million degrees Celsius, then the energy generated will be enormous. Fusion develops energy via atomic nuclei capture, whereas chemical rockets generate energy via the breakdown of molecules. This process has the possibility of creating orders of magnitude more energy than combustion at the source. Many forms have already begun the race to create a fusion-powered plasma engine. For example, the Helicity company is developing the so-called fusion drive, which, while using plasma confinement and magnetic field, operates only in short pulses, thus not requiring long-lasting fusion. This is huge because one of the greatest obstacles of fusion technology is how to sustain the reaction long enough to be of utility. That is why Helicity's approach avoids this problem while emphasizing the propulsion systems rather than the constant power generation. Another company, Pulsar Fusion, has set its sights much higher. They said their plasma engines could ground spacecraft moving at a speed of up to 500,000 miles per hour, thus significantly cutting down the time required in interplanetary travel. By employing electromagnetic fields, these engines confine and shape the plasma toward the corresponding nozzle, therefore expelling the plasma in the creation of thrust. Should the technology work as expected, the use of this technology could spell the end of long-drawn space missions whose duration ranges from months to years. What marked the advantage of plasma engines is where it is most used, and that's in space. Unlike rockets that consume fuel rapidly and thus can only offer steep profiles over relatively short distances, the plasma engine promises the steady acceleration of spacecraft over vast distances. This is where the idea of a rocket can give an object an incredible start-off velocity, but is not very capable of sustaining the acceleration. As for the plasma engines, they are capable of delivering thrust over some time, and in turn, a spacecraft gets a gradual boost in its speed. This makes them more suitable for space explorations than normal rockets, which would find it hard to maneuver in space. Currently, the most promising plasma engine, known as VX200 in the Vasimir project, is capable of heating the plasma at up to 4 million degrees Celsius. VX200 would be anywhere before it reaches the fusion level temperature, but theoretically, the spacecraft could go beyond 120,000 miles per hour. But these engines would require about 200 megawatts of power to operate at their maximum capacity, something that is hard to come by with today's technology. Peculiarly, the finest source to energize such a system is the prospect that plasma engines are trending toward nuclear fusion. Therefore, will plasma engines destroy rockets? No, not quite, not in the short term. Rockets are still the most ideal solution to payload launching from the Earth's surface, owing to the force required to counterweight gravity. Nonetheless, plasma engines are seen to be a potential candidate to be used as a form of propulsion system when in space. Their efficiency, high speed, and possibly the use of fusion as power make these vehicles suitable for long-distance interplanetary travel. This is the new generation of propulsion in the making. Plasma engines, more specifically those that can contain and use fusion, could revolutionize space exploration. These advancements are happening right now, and if the trend is to be followed, one day, the next vehicle to move out of the Earth will not be propelled by rocket propulsion, but by plasma itself.